So this, I think, is interesting and important from a red team point of view. If you're just angry at somebody like Donald Trump, then I think you cannot benefit much from understanding what he does. This is a general truth, if you'll let me delve into religion and philosophy a bit. If you have an emotional response to something, then you're not thinking clearly. And one thing about Donald Trump is that he is the world's champion social engineer. He manages to keep an enormous number of people on his side, no matter what happens. And here they're analyzing it. I think he manages, by contradicting himself and changing things and randomly abandoning his promises, he manages to arrange that he can take credit for anything good that happens, and he can blame somebody else for anything bad that happens. And this is an interesting strategy from a social engineering point of view. Anyway, the U.S. is now going to give a $5 million reward for information on North Korean hackers because they are attacking the financial system. And the claim has been made many times by the experts here that North Korea's economy is funded almost entirely by money stolen with cybercrime, primarily by hacking the cryptocurrency marketplaces, which are certainly rife with fraud and abuse. Anyway, it'll be interesting to see if anybody turns them in. It seems to me that the North Korean hackers are pretty much locked into a system where they don't have external people who could collect that reward and benefit from it. But one proposal I saw on Twitter does make sense, which is maybe the government will turn in people just to collect reward. So this is interesting. There were people trying to explain that, for example, on Fox News and a lot of the alt-rights trying to say that COVID-19 is just like everything else, just like car crashes or the flu or anything. And it's interesting to see how it is. One thing about it is it spreads much faster. That seems to be the special thing about this flu, is the COVID-19 virus spreads much faster. Now, another thing about it was it appeared to be 10 to 20 times more deadly, but that may not be true. However, what certainly is true is that it spreads much faster. And that explains why the scientists have said we really have to take the economic pain of staying at home to slow down the spread, because the spread is a big problem. And the spread of these other things is not such a big problem. Anyway, so colleges are all moving online like we have. And a bunch of them that are really expensive are continuing to charge full price for tuition, and the people paying that tuition are not appreciative. Let's see, here we go. All right. Anyway, so it's an interesting issue. That's why a lot of colleges are canceling classes and cutting. They're afraid of losing enrollment because people aren't willing to keep paying these $28,000, $27,000 bills for what they imagine will be much inferior education, as everything is done over Zoom and people aren't really getting to go on campus and be in the fraternities and have all the other experiences that they're paying that large money for. It is possible that more of them will go for free options like City College. So it is possible that our enrollment might go up, although current information I'm getting from administration is they just want to cut everything more because they don't think enrollment's going to go up. I don't know which way it's going to go. Supposedly sometime in July, we will have information about whether enrollment has gone up or not. So VMware had a absolute maximum rated vulnerability. Apparently, vCenter management had an unauthenticated remote code execution you could use to create an admin level user. So that's pretty exciting, although that's not a product that most people run on a desktop. You run it in server farms. So anyway, I'd sure like to set that up and see it go, but anyway, it has been fixed apparently. And so Pulse Secure had a big vulnerability, and companies are getting hacked even after they patched it, because while it was not patched, they stole credentials. And they're using those credentials later. So as you'd see in a breach notification, once you have a serious vulnerability, it's not enough to just patch it. You have to change all your passwords, which I think is what's missing here, although there may be a little more to it than what I understood. The Air Force had a bug bounty. The Department of Defense has had 2 or 3 of them. And so the Air Force had a bug bounty, and apparently it was quite successful. They paid out $275,000. So that's very nice. I'm really glad to see these things becoming common. Although they are somewhat problematic, they certainly make it a whole lot easier for vulnerability researchers to get treated with some respect instead of treated as criminals if major military organizations are letting them do it. Anyway, so we're required to wear face coverings in public in San Francisco now. I went out to the grocery store and most people were in fact doing this. So anyway, I think this is a very positive step. I think if you're sick, it certainly lowers the chance of you spreading it to someone else and probably also protects you if people are coughing around you. So once again, I see San Francisco right at the front being very successful at social distancing far more than the rest of the country. And I think we are setting an example for correct behavior here. So Bill Gates said that his whole mission since he quit being at Microsoft and turned into a philanthropist has been to fight disease with vaccines and such. And so, of course, when this coronavirus hit, he was right at the front of research and recommendations. And he was very upset with Trump for canceling our funding of the World Health Organization. He says, you need them. That's crazy. He is, in fact, the #2 funder of the World Health Organization. The United States government funds them at $500 million a year, and he funds them at like $150 million a year or something. So I think he's increasing his contribution to compensate. And in result, a whole bunch of alt-right trolls are attacking him, death threats and everything else. He's getting hundreds of thousands of abusive tweets and such. I've heard this from a lot of people. I guess I'm not important enough to be the target of a troll army like this. But anybody significant that says anything opposing Trump, they get attacked by a giant army of alt-right people and probably Russian bots and such. And they spread conspiracy theories. The one they made up about Bill Gates is the reason why he is trying to promote vaccines is because he's going to make the company that makes the vaccines and he'll get rich selling them, which of course he is funding research projects to develop the vaccines. But I think it is ridiculous to suggest that he's trying to make money. He's obviously got piles of money and he's in fact spending his life giving it away. Anyway, this is the study, which is very interesting, from Santa Clara County, California. As you know, there's a huge shortage of testing capacity in America, so we cannot find out who's got coronavirus. But these people did a sample of 3,330 people and tried to correct statistically to get an estimate of the prevalence of the antibody, and they concluded that something like 3 to 4% of the population has already had coronavirus, which is much more than people suspected. But one thing that people have said all along is that we don't have enough tests, so we really have no idea. When you see the reported number of cases, it's the number of people that have tested positive, but most people never get a test. And this echoes something we've seen from a similar experiment when they tested everybody on an aircraft carrier. And they found that a lot of people have had it and they were asymptomatic. They never got sick enough to care or go to a hospital or get tested. So that is very interesting. And it's interesting to try to figure out what that means. One thing I would think it might mean is that maybe we should abandon all the social distancing because there's no, well, this global social distancing, shutting everything down is the only thing that could work. Any prospect of letting people go back to work would seem to be contraindicated. If 3 or 4% of everybody has it and they have no symptoms at all, I don't know how you could catch them unless you make everybody take a test like every week or something, which is what some people have said. They say we have to get up to that level of testing, which is 200 times more tests than we have before we can really open up the country again. Anyway, so this class, as all the City College classes, is nearly over. The schedule is a little strange, but by the time you hit midterms, there's only a few weeks left. So here we are at 418. So I'm going to talk about Windows overflows and demonstrate some sort of pedantic things about what's happening inside Windows. And then there's a Pacific Hackers online event, which I highly recommend. There's 3 of these coming up. I recommend going to them. And next week, this class will be an hour earlier to make time to go to this. So I recommend going to this. If you do, it's worth extra credit. Just send an email to where your homework goes and tell me you went to it. And so that's the schedule. So let's take a look at Windows overflows. I've got a slide deck about it and then some demonstrations. And I think I'll put the demonstrations off a little later than usual because unfortunately, my machine doesn't seem to be capable of running VMware for a long time without running out of power. You see, I've gone down to 7%, so I have to leave the VMware off for a while to build up some power. All right, so there's stack protection, heap overflows, and the other overflows. And we're going to talk more in detail about Windows defenses. Microsoft Windows has many of the most powerful and most modern defenses because they're in the front of security. They get most of the attacks and they've turned on most of the defenses. Now, we talked about Linux. If you're in Linux and you use GCC, and you make a one of these vulnerable software packages that we made a lot of, where this has a buffer overflow vulnerability, where you have 10 space for storing 10 characters. Let me make sure I'm recording. I am, good, okay. You have space for 10 characters, but you let them put in more than 10, so you've got a simple buffer overflow vulnerability. So you can compile it the normal way, or you could compile it without a stack protector. By default, there's a stack protector on there. And what that means is if you compile it without a stack protector, then it looks like this. If you add a stack protector, then you will see this added code in the prologue, where it goes to this GS segment register and 14 bytes beyond it and downloads something and stores something there. So that is the cookie. It creates a random value somehow. It stores a copy of it in another segment. Then it stores that value at the end of the stack frame. And if the stack frame is overflowed, the cookie is modified. And so when you go to the epilogue, instead of just leaving and returning, it checks. It pulls that value back and compares it to the value it found on the stack. And if it has changed, then you have a stack check fail, and then it will not continue running the code. So it's intended to make it difficult for you to engage in a classic buffer overflow. And of course, the same thing is present in Windows. So if you use Visual Studio and C++, which I'll demonstrate a little bit later, you can compile the same code on Windows. It's very nice. It has a command line compiler called CL, and you can compile with and without stack protector. The /gs- switch gets rid of the stack protector. And as you can see, the code without the stack protector is a little bit smaller, 215.040 instead of 215.552. So it's a few hundred bytes smaller. So the stack protector does have some overhead costs. And you can disassemble them with IDA free, and you can see the difference. So here's the code without a stack protector that enters a subroutine, and down here it asks you for a password, and it's going to put it in a variable that's not able to carry a long password. And here, before it does that, it creates a security cookie and stores it someplace. So you'll see a few extra instructions about the security cookie when you enter a routine and when you leave a routine. So that's stack protection. So this is the /gs compiler flag is on by default. Microsoft calls these things security cookies. It's the same thing in Linux. They call it a canary. And that's a 4-byte value placed on the stack. And it places the stack here before the saved base pointer and the saved return address. So if you have an overflow in some string variable and you're able to write in this region, you will clobber this cookie before you hit the returned address, and therefore it will prevent you from being able to control the EIP by using a simple overflow. So now you have to make a semi-random number, and this is a big problem in computing. There are many security flaws that come from inability to make a random number. So Windows combined the date time, counting time down to 100 nanoseconds, process ID, thread ID, another timer, and a performance counter, just trying to find enough things to make effectively a random number. But this means if you are able to get code execution on the box, then you might be able to get those time values. Now, Microsoft and many people might say, well, you already got code execution on the box, so what's the problem if you can further extend that to perform a buffer overflow? And that may be true. So the actual consequence of this may be small, but it still measures the value of Microsoft's defense. And effectively, against that attack, since you can predict some of the values, it's really not a 32-bit random value. In fact, there's effectively only 17 bits of randomness. These bits you can predict, which is why the accuracy of them is near 100%. These bits you can't predict, so the accuracy of attempting to predict them is near 50%. So 17 bits of randomness means that you have one chance in 130,000 of guessing that random value. So that means one way to overcome this defense would be to just run your exploit 100,000 times, and by then you'd have a pretty good chance of just getting lucky. So that sounds pretty good, but it's a good way to measure the strength of a defense. All right, so the prologue modification shows that there's a security cookie in a carefully calculated position to protect the base pointer and the return value. And it has an epilogue modification that will call this security check cookie that makes sure that that value has not been modified. So it compares it to an authoritative value in the data section. And if it fails, it then jumps to a security handler, which will now shut down the program and pop up an error message or something like that. So another defense is parameter order. If you define variables, and they are local variables, they used to just appear on the stack in the order in which you defined them, but now Microsoft sanitizes them. So if you define some long string arrays, string variables, and then some non-string variables, it will put the non-string variables first. And that way, if you overflow out of the string variable, you can't clobber non-string variables. So you can't have the simple kind of buffer overflow, the kind we did in the very first project, I think, where you leak out of one variable into the next variable. And I remember saying at the time, this is not the most common or the most powerful type of buffer overflow, but it is the most difficult to stop. You're storing all this data on the stack, and if they put in just like 25 characters in this name, so you change a little bit of the next variable, there's not easy to prevent that at all. And all of Microsoft's latest defenses still can't prevent that, but you're not controlling something that obviously goes into the extended instruction pointer. You'd have a very specific problem with the program. It would be quite a challenge to take over control of the program with that kind of overflow. All right, so when you're overriding parameters, if you have a buffer and you overflow it, then you're altering all these parameters that you write into after that, and that's the point. All right, so you change the cookie. Now, if you do this kind of parameter and you overflow the cookie, you're going to get busted when it chose to stack check fail, but the program will run up to the point of stack check fail. So you might be able to exploit some functionality that occurs before the stack check fails, or you might be able to overwrite the authoritative cookie value so the check will pass, or you might be able to overwrite the pointer to the handler so that when it fails, instead of just terminating execution, it goes to something you can control. So there's always a way past every defense, but you've certainly made it much harder than the simple buffer overflows we've been doing. And as we know, you can do the same thing in the heap. So if you have some software like a web server that takes in requests and uses them and then it's done with them, it puts them in the heap so it can allocate the memory and then free the memory for reuse to be efficient. So every process running on Windows has a process heap, and there's a API call, get process heap, to get a handle to it. And a pointer to that is in the process environment block here with the FS pointer pointing to it. So you can get it out of the pointer. And that default process heap is where a lot of functions store their temporary data. You can also create dynamic heaps inside the default process heap to have a separate series of heaps for different processes. Another way to go. So your default heap is here from the process environment block, and then your code may create a dynamic heap while it's running, or a series of dynamic heaps that are inside there, and there are pointers to the dynamic heaps as well. So you use heap allocate to borrow a chunk of memory, or you use the legacy functions local alloc and global alloc. And when you're done, you call heap free, or the older functions local free and global free. So the stack goes down, the heap goes up, and it starts with list entry structures, which keep track of the blocks. As we've talked about before, the heap is a linked list. So each node has data, and then it has a forward pointer and a reverse pointer. So it has a pointer telling it where the next node is, and a pointer telling it where the previous node is. And when you delete a node in the middle, when you free it, it has to update this pointer to point over here, and has to update this pointer to point over here. And that means that if you were able to overflow one of the heaps, you'd be controlling both the address and the data to a write operation. So you would get an arbitrary write operation under your control. And there's quite a lot more to it in Windows involving a Lookaside list and other structures. But anyway, that's the main point here. So then you're going to overflow some. Now that you can execute a write operation, you have to overwrite a pointer somewhere to an exception handler or the unhandled exception filter or something like that. All right, so if you overwrite a pointer in the process environment block, this is one way to do it. You can restore this pointer when you're done. All right, in Windows 2003 Server, it doesn't use those, but there are other pointers you can go to, and these are ways to try to avoid damaging the heap too much. So vectored exception handling is the technique we've been seeing in the structured exception handler, where you have a series of functions that are called in order. And one possibility would be to overwrite the unhandled exception filter. So it is another way to get control of the machine out of your write operation. Anyway, when you do an overflow, you corrupt the heap. And if there was a check heaps process like there is in a Cisco router, you'd get busted. Cisco routers, every second or two, start at the beginning of the heap and hop to the end and then come back. And if anything's wrong, they reboot the whole system. Microsoft doesn't have that, although it does have an increasing series of defenses as time goes forward. So you might want to repair the heap. You do an overflow on the heap, and then you do something to repair the heap. One simple thing would be to just change some pointers to make the heap look like a fresh, empty heap. Or you could create an endless loop. There's another way to do it. If you cause an exception, that's one. I'm not quite sure how you benefit from that, but that's another way to do it. All right, and now we should talk about component object models. We've talked about these before. These are created when needed by another program. So you have a service listening for requests, and when that service requests access to the component object model object, it is created on the heap. So it's controlled by this table, a V table of pointers, and all COM classes have interfaces, which are used to connect them to programs. So your COM objects have programs and data, and since there are data fields, there might be overflows, and then you can leak into the next object's vtable entry from one object in the component object model list. It turns out that there are a ton of these things in Windows, hundreds of them, even thousands, and a lot of them turn out to be vulnerable, and they're for old versions of Windows and not used anymore, and instead of actually fixing them, they just have a kill list of ones that are known unsafe not to be used. Microsoft tried a similar procedure with ActiveX controls, which turned out to be very dangerous. They tried to just have a safe flag in the ActiveX control, and then, of course, bad guys learned how to set the safe flag in their malicious code, and it's the same thing here. This kill bit is not very strong. You can run the Olay COM object viewer and see them in your Windows machine, and there are just tons of them. And these are things listening that will create objects with code on them, and a lot of them are vulnerable. So anyway, then there's some other overflows. You can, in principle, overflow right in the data section. If you define code variables in a C program up here not inside any routine, they are not local variables. They are not stored on the stack. They're stored in the data section. And yet you can still overflow code in the data section. This buffer could, in principle, have a write operation to it that writes more than 32 bytes, and then you would alter these other parameters. All right, and in principle, you can overflow buffers in the thread environment block, but there are no known examples of that happening. But there are many data structures, and in principle, any of them could be overflowed. So let me do the Kahoots, and then I'll do some demonstrations here. The Kahoot should be here. All right. And this is 127 here. Oh, maybe there are not enough students for Kahoots. Well, I guess with only 2 students, we cannot do the Kahoots this week. I'll put them off till next week. So let me just boot up my machine and let's look at the examples. There are 2 projects I want to demonstrate here. Let me bring them up here. The projects that are relevant for today are here, Stack Protection 1 and 2. And I just want to show you how those look. So let me start my only 5%. Well, I'm afraid I need to just end class early because I've got a power problem. I'm not going to be able to demonstrate this right now. I will have to do it next time. So I may mess up our schedule a little, but I don't think I can launch VMware and demonstrate anything with only 5% power left. I'll have to make sure my machine is fully charged next time. So I think that's it for today. I will have to try and cover a little more next time, which may make us late for that event. In any case, I recommend today that you go to this event, this online event, Hacking and Pivoting Threat Intelligence. It might be good at Pacific Hackers. It's a free online event. Just click this link on my homepage to go. All right. Have a good day, folks. I'm going to shut down stuff and charge this thing up a bit. All right. There's always something. I would like to stop the recording, but the controls are strangely absent. Here they are. All right. And end meeting. All right.